everyone. I hope you're all well. Thanks for joining us today. My name is Jesus Mingaro. I lead the sales team here at Prosperon Network. I've got here with me Robert Mandeville. Robert, are you with us?
It helps if I'm not on mute, but yes, you do.
That's perfect. Thanks for joining in, Robert. Could you please introduce yourself?
Yes, my name is Rob Mandeville, and I'm actually currently the product marketing manager for a product called Database Performance Analyzer for SolarWinds. But just so everyone knows, I'm not just a marketing guy. I have a very extensive history and experience with databases, everywhere from production DBA to development to designer to architect, data modeling, you name it, I've probably done it.
That's very impressive. So what you're going to be kind of, I guess teaching is perhaps a good word to use, obviously. What's the topic that you're going to cover today, Rob?
Yeah, so today I'm going to talk about a topic that is very near and dear to my heart, and it's really the difference between health or resource consumption and performance from a database perspective.
And why is perhaps that's important and it's so important now, whereas perhaps 5-10 years ago, I would say that users were a bit more oblivious to the difference between obviously what health and performance mean when looking after databases.
Yeah, I agree 100%. And even when I, first started in my current role, which was about a year ago, I really sat down and started to think about the two. And I think a lot of people still think health and performance are synonymous. They kind of mean the same thing. And the more I thought about it, the more I thought that yes, there is a relationship between health versus performance, but it's more in a relationship of distant cousins than siblings. So helping people understand the different vantage points or the different kind of questions that you have to ask and answer from a perspective of health versus performance really helps them understand, first of all, the approach of our tool and why Database Performance Analyzer is really different from anything that's out there currently.
Brilliant. I'm sure that all these questions will be clarified later today. So just a reminder to everyone, today's webinar is interactive and it's very, very important to count with your participation in order to keep this session as useful as possible and kind of ensure that you walk away with valuable insight. For that, we'll have primarily two ways of getting your input. The first one is voting on the polls that will be displayed on your screen, and we'll be asking you a couple of questions throughout the session, and we'd kindly request that you submit your answer, because based on them or the responses, we can steer better the content displayed and demos and the scenarios that we're going to be discussing. And finally, the other way of interacting with us is going to be asking direct questions, that you can do so by typing them on the chat box that you have on your GoToWebinar panel. We'll be monitoring this closely, and on each session we'll read them back to Rob so that he can answer or reply to your questions as they come. We will also have a Q&A session at the end, so if for whatever reason we're not able to cover them as soon as they come, by all means they will be covered later. And having said that, the first poll I'm going to launch. If you guys could please vote. Polls are coming through, and they are still coming through, so we're gonna give it a few more seconds. Perfect. So let me close this poll and share the details with you, Rob. I think is interesting. So here we have the results of the poll. So yeah, I think it's very promising, is it?
It is, yes.
Brilliant. All right, so let's move forward. Just a bit of introduction about Prosperon and who we are. We're the leading UK authority on deploying, tuning, and training users of SolarWinds product. And there's mainly three reasons or categories why you guys or customers engage with us. Primarily, we have customers that are already using SolarWinds. Some of them are new to the tool, and some of them have been using it for as long as we've been in business. But there's always a common denominator, and is that they're looking to improve what they get out of the tool. They may be looking for ways of optimizing the platform, either based on performance or perhaps based on usability. They could be looking at implementing best practices, putting automation procedures in place, or just looking for assistance with upgrading their module. They may also be looking at ways of increasing their efficiency of the tool by integrating it with other systems of their ecosystem. We also engage before implementation. That will be perhaps the section 2. Perhaps when SolarWinds is being benchmarked against some other options, these customers may be looking to understand the implications of implementing SolarWinds. They may be looking for recommendations around architectural designs, about planning, and in some scenarios, they may just be looking for a company that can document them and provide a piece of document that can summarize, the whole project from the commercial aspects all the way down to low-level design documents and etc. And finally, we also have customers that will reach out to us purely for assistance once the tool has been implemented and is in place. This will include both technical support as well as general advice on how to achieve certain things, or get a second opinion when looking at your strategy for a monitoring perspective. Now, what backs up the level of service that we try to provide to customer is our experience. When Prosperon was founded, SolarWinds had only one product, NPM, and if my memory serves me well, it was around version 7. We're talking about 11 or 12 years ago. Without going into too much detail, I'm sure that most of you know that they have grown astronomically since, and that also includes acquiring Compio, which is obviously the company that Rob used to represent. We've been exclusively for these 11 years focused on SolarWinds. SolarWinds is pretty much all we do. We breathe monitoring and have been engaged with some of the largest deployments of SolarWinds in Europe. And pretty much all of our engineers are SolarWinds certified, and from the screen you can see that they're on site pretty much 1 of every 3 days. So what that means is that we get exposure to a variety of scenarios, from highly secure installations to deployments large and small, and pretty much across every vertical. So we tend to understand the hurdles and challenges that you need to go through, and that the resources that you have available are 100% limited. So we always be aiming at engaging with you in the most efficient and in the most efficient way possible, and keep integrity as kind of the foundation of what we do. Just to summarize, this screen outlines the added value that is provided when you guys engage with us and renew your licenses through Prosperon. Support is certainly one of the major ones. We complement SolarWinds' own support, so they get resolved. So in practical terms, this means that when you request and support to us, either you get a response from us directly, or if it needs to be escalated to SolarWinds themselves for whatever reason, we'll manage the escalation process on your behalf. So you spend less time chasing and getting resolution. On top of that, you get a free health check of your SolarWinds platform. And I think the reason why this is quite relevant is because after having performed more than 150 health checks over the last couple of years, we keep seeing the same gaps. And it's not necessarily talking about how attractive or clever a network map may be, but rather the fact that not many of you are using SolarWinds advanced features as well as you could, perhaps, and in some cases they are not used at all. And that what the frustrating thing about this is that obviously people are constrained by resources. However, making use of these advanced features, they could contribute massively in reducing the time that you need to spend managing the SolarWinds platform, and obviously troubleshooting, and by implementing automation tasks whenever possible. So there's some good news though, as the SolarWinds module that we're going to be discussing today, I think from my perspective have most of that functionality already built into the tool. I certainly leave Rob to explain this in a bit more detail, but there's certainly differences in between how DBA can help you manage your database state, and obviously the recommendations and assistance that can provide to a DBA. There's huge difference between that and the more, let's call it, traditional way of monitoring that obviously the rest of the Orion platform will be part of. Having said that, Rob, I think that you want to take things from here.
Yeah, perfect. Thank you. And that polling question was kind of revealing in a little bit. It looked like a lot of people were familiar with SolarWinds for sure, but quite a few with Database Performance Analyzer as well, and some of them are actually using the product. Hey, Seuss, one of the things that I usually like to say anyway is that DPA, which I'm going to refer to as Database Performance Analyzer at this point, really doesn't have any competition. I know that there's other database monitoring software out there, but they tend to really be focused on health and resource consumption, as I mentioned earlier. That's a different proposition than, say, database performance. So let's dive into this whole concept of performance versus health and kind of see if we can tease it apart a little bit, because I think it really does answer different questions.
I think it's important the point that you've made, because when you're trying to compare DPA to other products, if you look at the data sheet of other products, they also going to say that they don't have competition. But I guess that the point that I'm trying is true. That, the point that I'm trying to make is, unless that the distinction between what health versus performance mean, is very, very difficult for a database administrator to really understand the differences between DPA and any other major DB-focused product, I guess. So.
Yeah, no, very true, very true. So to start out with kind of teasing it apart, the first thing I'd like to do is, and I recently did this in a survey, just kind of an informal survey, but if you ask 4 DBAs what their definition of database performance is, you'll probably get like 10 different answers. And this goes back to one of the favorite responses from a DBA is, well, it depends, right? So since this can be a bit of an ambiguous topic, yeah, we'll start to tear this apart a little bit. So first, let's start with health and capacity. So really that speaks to, what resources do I have at my disposal? Is there anything creating an impediment? Are all systems go? Are things healthy, right? Is there a lack of illness or some kind of, take your own personal health. Do your legs work okay? Are you okay? Do you have an illness? Do you have any kind of sickness that would prevent you from achieving? So that's pretty basic, and hopefully just about any monitoring tool should deliver at least that. Okay, so now let's take that and let's move on to utilization. So this really speaks to resource consumption. So as another example, let's take max heart rate as an example. When I put load on it, like let's say you put me on a treadmill and I start to jog, does everything look good? Hopefully I'm not passing out or anything like that. How much of my max heart rate am I consuming at any given time? Okay, so now we're solidly into resource consumption versus capacity. So we're actually using some of these resources, you're utilizing it. This is important. And by the way, we do need to know both of these kind of things to make sure that this is a pay-to-play kind of monitoring. But you need to know if there's any contention or if anything's being pegged. In other words, have I maxed out on any of my capacity or utilization? So that is key to understanding, right? Because that will certainly cause a performance issue. So with all that other information, though, about capacity and usage, can I still tell if my database is running well? So that's where we start to get into a different kind of concept. We start tracking performance. So I feel like in my own discussion, like something just shifted there. So wait a minute, Rob, you were talking about resources and consumption. Now you're talking about saying performance is something different. But that's true. They're not really the same thing. They don't really answer the same questions. So if that's what everybody on the call is thinking, you're right. I did just kind of shift the conversation a little bit. So let's go into an analogy that I like to use to kind of underscore the difference here. So you go to your doctor. You ask him if you're healthy. What's he going to do? He's probably going to do some blood tests. He's going to check your cholesterol. He's going to check your resting heart rate, your BMI, which I call the fat test, all those kind of things. This is good data to have for sure. But now if I ask him, okay, doc, can I run a 6-minute mile? Can he answer that with that data that just provided him or that he got from those tests that he ran? And the answer is no, because now we're talking about something different, right? Health is the absence of anything that would prevent you from achieving, but performance now is actually going out there and achieving. So that same doctor would have to go out to the track with me with his stopwatch and start clocking me as I run around the track and see if I can run a 6-minute mile. At this point, I probably can't, so full disclosure. So let's get into the, yeah, maybe at one point in time, probably not now. So I hope that that analogy kind of clarifies this a bit conceptually. And this is what you're seeing on the screen right now is the best definition I've seen so far, and I've modified it a little bit because I added a time component to it. So really the optimization of resource use to increase throughput and minimize contention, enabling the largest workload to be processed in the shortest possible time. So I kind of added to it. I took this from a Craig Mullins quote, but I added the shortest possible time because I think, when you're talking performance in most aspects, you're talking there is a time component, right? If we're watching a car race, if we're doing a running race, if you're into biking, whatever it is, your performance definitely has some kind of goal that's usually associated with time. So we could likely have a philosophical discussion about this definition, but I'm hoping this works for most folks out there. So if we're okay with this definition, then to be able to measure and track performance from a database perspective, what is required? So I really sat down and thought about this definition and what it would take to say, yes, I've captured all the data needed to understand, do I have a performance issue or not within my database environment? So this checklist is something that I came up with, and I'll give you a moment to read it. And you've probably been looking at it a little bit here since I've been talking, but this really goes into the heart of it and says, what all do I need to capture to understand my performance picture? And this is it. These are the, what is there, seven items there? And really that's to say that if you're missing any of these, you really kind of have a gap in the picture, right? And the more you're missing out of these, the bigger the gap. So you should be measuring some kind of measure of time at the activity and the query level, a way to tell resource consumption, and if it's driving the performance problem, right? We talked about that a little bit. Am I maxing out CPU? Is my active memory? Am I flushing, data out of cache too quickly? That kind of thing. A way to determine if concurrency is impacting. By the way, concurrency is one of those things like locking and blocking that will never manifest itself in any kind of resource pressure. So we have to have a different way of looking at that. You have to have a way of measuring workload, right? It's a big difference between a query running once and consuming 10% of the CPU or running 1,000,000 times and consuming 10% of the CPU. So you need a way to triangulate and coordinate the issue across dimensions. So this really dives into the who, what, when, where, why, and well, especially the why, right, on that, to be able to answer those kind of questions. You have to have a way of capturing the actual execution plans. You have to know what the optimizer is thinking at the time that the execution was happening. If you're missing that piece, you're missing a big gap because you can't go back in time. You can run like an estimated plan right now, but to actually capture what was running at the time of the execution is huge because the optimizer can change plans on you, and that can be a big issue. I've lived that one for sure. And then also a historical look at your environment. And this one I think everybody would agree with. It's like you got to have a baseline because if you don't understand what that historical picture of your environment was, how can you tell if today is better or worse? So you have to be able to understand that norm. Okay, awesome. So Jesus, can you go to the next slide? Perfect. Okay, so once we can measure these things, once we can collect all that right data, that gives us a really good picture of our environment. So really, ideally, all of my SQL statements, if I had my choice, would be spending all their time processing. So let's talk about that for just a second, because a lot of times monitoring products, including SAM, will give you a picture of queries by CPU utilization. So they will say, here's your top queries by CPU. And maybe that's fine if your concern is CPU, or that might be the bottleneck in your environment. From what I've seen in the past 10 years, CPU has absolutely not been the constraining factor. Network either. I used to love to blame the network guys, but it's just so fast now. The bandwidth there, so huge, and clock speeds on chip architecture now has gotten so good. So it's really tough to blame physical resources anymore. Okay, so if CPU is not the best measuring stick, we probably have to look at it a different way now. So we have a phrase in the US that goes something like, don't move my cheese. And I'm not sure if that translates, across the Atlantic, but it basically means something significant has changed. It's like the mice looking for the cheese in a maze, and it's been moved on them and stuff like that. So going back to this concept of, what are things doing in my environment? Really, a process can be in one of three states at any given time. It can be running, runnable, or suspended. So the running and runnable, if you think about it, like you're in a grocery store, and if you are at the cashier and they're actively checking you out, you can consider yourself running, meaning you're being processed. And that's a good thing, right? You're getting ready to get out of that store. That's cool. If you are in line or in queue, then you consider yourself runnable. It's like you're ready to be checked out, but you're just waiting to get to a cashier. You can think of those cashiers as your processors. Those are your cores. So if you're doing anything except for being checked out or waiting in line to be checked out, you're actually suspended, right? Maybe you're looking for another item. Maybe you're asking for a price check. Maybe you had to run to the restroom or something like that. But basically, those are your suspended activities. So by focusing on running and runnable, that may not be the best thing to indicate performance, because that is actually productive, right? You're getting work done. You're getting checked out, or you're ready to get checked out. And actually, from a database perspective, those are the easiest things to address, right? You can always throw more processing at something. Keep in mind that there are licensing concerns there, of course, but you can throw more processing at it. You can throw faster chip architecture at it, and you can, if CPU is your constraint, that's easier to deal with. What's tougher to deal with is this suspended activity, and that's where we're really getting into the wait types or wait events, depending on your database vendor, in your database engine. So ideally, again, I would want all my SQL statements processing. If they're taking CPU, you know what? That's what they're supposed to be doing. Okay, so collecting all these things like time, usage optimization, my throughput, my contention, my workload, gathering all these things means I have the ability to do true root cause analysis. I can really dive in and say, yes, here is what's happening within my environment. We're tracking the time component across all of these different dimensions, like I mentioned. So you know what the query is, you know what the database is, you know what the client machine is, you know what the program is, you know what the query plan being used is, etc. So we do capture all of that information that's necessary. All right, do you mind going on to the next slide? So hopefully we're starting to get a better picture of what I mean by performance analysis versus resource consumption and other health monitoring tools. It's actually on the approach or the methodology to begin with. So I always like to say, if we're not collecting the correct information up front, there's no way that we can get to the right answer later. So remember in the last slide, I was talking about this suspended activity and stuff like that. From a database perspective, that represents these activities like maybe blocking or physical I/O or compilations or latch contention, kind of that memory locks and stuff like that, etc. So if you think about those all those activities represented and being reported as wait types or wait events, those are your database engine actually instrumenting itself. So if anybody hasn't heard of bytecode instrumentation, I will be the first one to introduce it to you. You may be very familiar with this concept, but basically it's from an application point of view. It's putting code in your code to tell you what it's doing, how long it's doing it, kind of doing that deep dive analysis of performance from that application side. So the wait concepts or these wait activities are actually the database being self-instrumented, right? It will tell you what it's doing for each query. All you have to do is ask and then translate that. So that's essentially what we do, and that's where our focus is. So if you understand what the database engine itself is doing and where it's spending all of its time, guess what? That helps paint a picture of your environment and tells you why the performance impact is occurring and tells you where the biggest bottlenecks are within your environment. So this definitely makes us different than other database monitoring tools. Again, a lot of them kind of focus on resource consumption, and we tend to focus on the waits first. And this little chart over here that you're seeing now, this performance analysis tool like DPA, we are wait time focused. We are able to triangulate the root cause. We collect actual execution plans. We give you that historical view or baseline. We have a time event specific analysis. We do pattern analysis to make sure that it's very easy for you as a user to pick out anomalies. But in addition to that, we do monitor the basic health of your systems, right? Because that is important. You need to know if anything's maxed out. You need a complete idea of the workload statistics. You need to know how many executions you have. You need to understand the logical reads, physical reads, rows process, things like that. We have the basic functionality of learning and reporting, of course. And this is to be compared with health monitoring tools, which kind of puts query resource consumption at the forefront. I won't read through all of those, but basically they do provide some high-level query performance analysis. They do weight class grouping at the database level. Worst queries are based on execution time, maybe CPU usage, things like that. They kind of percolate those up to the top. And they might even give you, I hate to say this, but they might even give you misleading information, right? I've seen in some of the products, and I'm using air quotes here that you can't see, but there are some products that will highlight a select star as bad in your database environment. And this is interesting because I usually ask this during an interview process of DBAs coming in, because I want to understand, do they truly understand the mechanism behind the scenes, like what the database engine is doing? So I ask them, is select star from table 1 any worse or any better than select column 1 / column 2 from table 1, like going after specific columns? And a lot of them actually say select star is worse, right? Because I'm actually getting more data. I'm selecting all the columns in a record. Hopefully there's a where clause in there somewhere, but I say, okay, well, walk me through that. Help me understand why exactly that is, kind of a worse conceptually. And after they kind of go through it and they're like, okay, so, you got to find the rows in the table. You have to read that into, those are usually held within a page or a block or something like that, depending on the vendor. That's read into cache. And I said, okay, good so far. And then they say, well, okay, so it's selecting specific columns and that's all it's returning to you. And I said, correct, but that is a network performance hit, not a database performance hit. Because in order to get those columns, the entire page or block containing all the columns for a record has actually already been read into cache. So you're not saving anything from a database performance point of view by doing a select star, because you've already read that data into cache. And at that point, the aha moment, the light bulb goes on. They say, oh, yeah, okay, good. So we understand that. All right.
I think that's clarified a bit, Rob, to be honest, and I like the analogy that you were using. I guess is as you said, comparing a visit to a GP to understand, what your levels of cholesterol are. If you go beyond that point, is perhaps having like a Fitbit or a wearable device that is telling you at some point, what your heart rate is and how long you're running for, and perhaps the more performance focused, I guess, category is having like a personal trainer that is just constantly with you and checking your stride and how long you need to run for and your rest times and things like that. So it was very useful using that analogy, I guess, to show the differences between health and performance focused tools.
Yeah, no, exactly. And another one that I use is kind of like with my kids. I always tell them they have the potential to earn straight A's, but it doesn't mean they always do, right? So there's potential or capacity, and then there is achievement. You can only say you've achieved or declare victory or declare success if you're measuring that performance and then putting it up against some kind of goal.
Absolutely.
Absolutely.
What
Yeah.
doesn't get measured doesn't get done, right? So
I say that all the time. I think you just stole my quote.
Perfect.
Great
So
minds, great minds think alike.
yeah, absolutely. There's the second poll now that I'm going to launch. Let's see, based on what Rob has been discussing earlier, for those of you that do actually have a monitoring tool, do you think that is perhaps more focused on performance or health? What are your answers? While we wait for all the polls to come in, Rob, we have a question, and is what are the databases that we can monitor with DPA? I guess that's obviously you will cover on the demo as well, but perhaps while we wait for all the answers to come through, you may want to clarify that.
Yeah, absolutely, and great question. So the platforms that we cover right now are really the operating system doesn't matter. We create a JDBC connection, so we don't actually have an agent that's running on an operating system, so we can bypass that. But the database platforms we cover are Oracle, SQL Server, MySQL, DB2, Sybase, and if anybody's out there running on Amazon RDS, we support Aurora. Actually, I should mention also from an Azure perspective, if anybody's on that cloud platform for database as a service, we do monitor SQL DB, so Azure SQL Database.
Brilliant. There's another question around, how much cost and things like that. We'll just say for now that's obviously DPA is licensed on a per instance. So depending on how many instances and the type of instances that you're monitoring, you're going to fall within a price bracket or a license tier or another one. But I can come back to you. The asker was Robbie Money. So I can come back to you offline, Robbie, and give you some indication once
Yeah.
we're done.
And I think that's a good way to do it, because I think since there is different tier breaks and stuff depending on quantities and stuff, it's probably better to understand someone's environment before you start to talk about the price.
Absolutely. Look at this. I'm going to share the poll results. It's pretty much equal between I don't have a monitoring tool. The tool that I have is able to do both, and the tool that I have only does database health. So only 10% will have products that do database performance. So
Which is kind of funny, because I think the original poll said that I think almost, what was it, 30%, maybe 20%, whatever it was, but there were some folks out there using DPA. So I would really hope that if you're using DPA already, you would have voted for the database performance, but perhaps not.
perfect. So moving forward, I think it's time for me to make you presenter, Rob.
Yes, that would be perfect. So now I'm going to launch into a demo and kind of give you an idea of, okay, how does this look in DPA, right? Let me share my screen here. And Jesus, let me know if you can see my screen.
I can indeed, yes. I can see DBA in the background.
Okay, perfect. So let's start here on our home screen. Let me dismiss that warning up there. Really, this dashboard provides you an overview of your monitored environment. We try to give you an idea of, out of all the instances, database instances that you're monitoring, which ones are experiencing the most waits, which ones are being impacted most. Waits being probably the best proxy from an end user perspective to identify pain, right? In other words, people usually don't care what's happening under the hood when you're driving a car. They just want to get to their destination. They don't really care what's happening inside the database engine. They just want to make sure that they're on time for lunch with their friends. So having said that, from an end user perspective, it's really the wall clock that they focus on. And that's why we took this approach in the first place when we developed this methodology and pioneered it. And it was to give that weight-based analysis, or this response time analysis approach. So you can see here all the different databases that I'm monitoring. You can see the different flavors of database platforms that we have. And I'm gonna dive into one of them down here. It's an Oracle instance, just for our purposes here. And that's kind of the nice thing too about DPA, is that regardless of the platform, so if there's any DBAs out there that support multiple platforms like Oracle and SQL Server and maybe MySQL or DB2 or something like that, since our approach is the same and our navigation is the same regardless of the database platform that you're monitoring, once you learn the navigation of DPA, it becomes very easy to jump from one to the other. So you don't have to be an expert in, say, Oracle to troubleshoot performance issues. Now, it will help to understand what fix to put in for the performance issue, but we can definitely help you identify it easily. So here, once I click on the instance, I get my 30-day view. This presents a really good picture of the top SQL in my environment for the past 30 days. And let's say that somebody told me, hopefully they wouldn't wait 2 weeks, but let's say somebody told me that back on July 14th, say, there was some kind of performance issue. So here's one of those use case scenarios where somebody comes with a specific time frame. They said, we had a performance issue back on July 14th. I can come in here and do a post-mortem on this by clicking on that day. And let's further say, yeah, this started to really go south around 10 p.m. And here I can easily pick out the anomaly here. If it wasn't 10 p.m., by the way, I can click into any time frame and continue drilling in that way. But by clicking on that time frame, you can see that even just a few clicks in, I've got some fantastic information about my environment right now. So number one, I can tell you the top SQL that was running at this time. I can tell you what the overall impact was in the amount of seconds to my end users for running this query. So this is about, a little over 6 minutes. And I can tell you what the activity was that this query was doing. So that's really the key part, right? So I can see that it was doing DB file scattered reads. And if I want to click on that wait event over there, it gives me a definition of what that represents. And it even points me in a direction like how I might get started in troubleshooting this, right? What are some directions I might go to mitigate this specific wait? And really a DB file scattered read means I'm going after the data, I'm fetching the data in a non-indexed fashion. So I'm basically causing a full table scan. If I click on that query, I get a great idea of what kind of workload it did in this 1 hour period. So I can see the number of executions, how many times it got parsed by the database engine, how many rows processed, my physical reads, my buffer gets, and really the predominance of my time, if I go back, I can see was spent actually getting the data from disk. And again, since it was a non-indexed fashion, I'm doing that scattered read. Okay, if I'm spending the majority of my time actually doing that physical I/O like I am here, I probably have a couple questions in my mind. The first being, well, is my disk performing adequately, right? Do I need to go talk to my storage admin? So that's where I click over to time slice, and I want to get a better idea of my disk metrics at that time. So here I can see that we had some multi-block disk read and some single block disk read. So this gives me an indicator of any kind of latency that I'm experiencing at the disk level. And I tell you what, anything below 20 milliseconds, I'm ecstatic with, especially for a production environment. So these kind of numbers or resource metrics for my disk access, my IO latency, I'm happy with. I'm not having to go talk to my storage guys at all. So they're off the hook. Now, when I look at my memory pressure, like the buffer cache hit ratio, and this is probably a metric that a lot of DBAs recognize, I'm crushing my memory. I'm not finding what I'm looking for. I'm not finding the data in cache. So I'm having to go to disk. So here I start to see that at least during this time frame, during this 10 to 1020, we'll call it maybe 1025, not ideal, right? Having to go to disk because whatever I'm looking for does not exist in my memory structure. So, and that's easily observed by the wait times above. So what I always say is let the waits tell you where to go look, and they will tell you if it's a locking blocking issue. They will tell you to go look at resources to make sure that you're not suffering from some kind of pressure there, but start with the waits. That's what I always say. So another way to use DPA, so that was a specific time frame, like somebody complained about, hey, I was having poor performance during this hour on this day and stuff like that, so we can go back and take a look at that. Another use case might be overall or like a general approach to reducing waits or improving performance within your environment. And to do that, I usually start with the waits tab because I want to better understand what is the primary activities that my database engine is doing, right, on a day-to-day kind of basis. So I can click on that and I get a good picture of, the primary activity usually tends to be memory CPU. That's a great thing, right? Actually, that's the activity that I would like to see all the time. But you can see that there are other suspended activities, things like the scattered reads, the sequential reads, the log file syncs during a commit, control file sequential reads, things like that. So, but a lot of those aren't very predominant. It's really the disk access, right? It's that physical I/O that's going on between these two file scattered and file sequential reads. So that's likely where I want to focus my efforts as well. And then again, if I correlate to the resource metrics down below, it will tell me, is this something I need to go talk to my storage admin about, or is it really a memory pressure issue? Do I need to go talk to my server admin, see if we can, or maybe virtual admin, and see if we can get some more resources allocated to this, maybe some more memory, so that when I go to look for that data, it's there in cache. The third kind of use case that I think of, and there's probably more, I'm just coming up with these kind of off the top of my head, but is, somebody complains to you right now that the database is slow or that the application is slow. Is it the database? So if I go into current, this is a great way, this is a very, very now kind of picture of my environment, and I click on show active sessions. If it comes back like this, like completely blank, then you know what? Nothing is waiting on my database to respond. So this is a great get out of jail free card. If people say the application is slow, I can come into current, I can click on current sessions. If it comes up with blank, then I'm like, nope, nobody's waiting on the database. Now, conversely, if I refresh this a couple times, and I'm hoping to get a hit here at some point, but I may not because it's probably fairly quiet right now. Almost, what, 2:30 my time? So
Yeah,
hopefully
I'll
not
be
a lot of.
concerned. I'll be concerned if someone is actually using the application at this time of the night. So
I would too. But if it did get a hit, then it gives you that picture of, okay, somebody is waiting on the database. You can go look at the last wait event activity. You can go look at exactly what SQL is running there. So if it's the database, it's essential for the DBA to be able to say, yes, it's the database, and I know why, right? So this is a get out of jail free card, but it's also a, hey, if it's me, now I have empirical evidence, or I have a good visibility into my environment that says this is what's happening, and now I know how to address it. All right, so that kind of covers the test cases here. And we also have many other great features within DPA itself, like a way to drill into, say, a specific query and look at its historical chart. And let's do that real quick. This is fantastic from a point of, is this query doing better today versus its historical running? How many times did it execute in the past? And it really answers a question of, if this query is running worse today, what's driving it? Is it the execution? So is it just pure volume? Is it the number of disk reads that I'm doing? Is it the number of buffer gets or logical reads that I'm doing? How does my rows process related to the executions? Also, what's my average wait time per execution? And here we can see that this one actually fluctuates quite a bit. Now, the good thing about this is that it's actually spending all of its time processing, right? So that's good. This is all CPU and memory. But I can tell that, hey, it took a lot longer to execute each time back on, what is that, July 2nd, than it did maybe yesterday, right? So this is something that I want to watch. And if it kind of bounces around like this, maybe my end users aren't impacted if it's running, maybe 10,000 executions or something like that. But if it's running 10 million times, even a slight change in milliseconds can have a huge impact on your end users. So another thing I use this graph for is trending, right? Am I going in the right direction? Am I getting worse as time goes on? Is my execution time increasing over time? We also give you a profile of the query. You can tell how it's being used. Is it an application? Is it end user driven? If it's end user driven, it's usually going to be that perfect like bell curve pattern where things start to ramp up around 8 a.m., maybe peak sometime midday, and then taper off toward the end of the day. So
we have one question now that you're analyzing a particular query. One of the questions that we have received is, can I create an alert that in DPA that would email me if there is any performance issue with a particular query?
Yes, absolutely. So if we want to toggle over to alerts, we have many different kinds, but one of them is a wait time alert. So if I want to, I can say the average wait time for a single SQL. Yeah, so I can monitor, especially if you as a DBA, you know that there's some kind of problem child within your environment and you need to really keep an eye on it, because if that thing goes south, then you know that the end user is going to call in, you're going to be spun up, you're going to be called at, well, 3:30 a.m. in the morning, that kind of thing. So yeah, you can compare it against the average wait time for that single SQL. And we use, in this case, for this particular alert, we do I believe it's 2 standard deviations. So once it exceeds or goes outside of those 2 standards of deviation from the norm, you will get notified.
Okay, makes sense. And I guess that obviously you could define different thresholds for different instances, right? So this will not be a global setting that you apply overall. It would be bespoke to each database if you wanted to.
That's right. So you can define different thresholds if you want, and we also give you the ability to define your own custom metrics if you would like. So the old custom metrics and also custom alerts. So really, in this extensibility of the product, this ability to customize it was really the idea of a lot of DBAs coming in that become part of our family. They have a lot of scripts that they've developed over the years, a lot of scripts that they trust to tell them different answers about their database environment. We don't want you to leave that behind. It's like, we hope that what we provide in DPA will address 95, 98% of your needs, but there's always that little bit that, yeah, but this is something that I've really loved to see over time. We say, don't throw that away, bring that with you, build it into the product, put it in DPA, and then that way everybody can enjoy or benefit from that. So, yep, lots of customization abilities, but we hope that we address most of the needs.
Makes sense. There's another question. It goes also tie into the first part of the webinar, between distinguishing health versus performance. Now, let's say that 80% of current environments or current databases are going to be virtual. Therefore, they're going to be installed on VMs that are going to be dependent on ESX host and so on. Can you, within DPA, display within a dashboard, perhaps the statistics from the different parts of the stack, so the database, the VM, ES host, and so on?
Yeah, great question, and the answer is absolutely. So if you're running on VMware, so we support the VMware hypervisor. We don't currently support Hyper-V. So if you are on Hyper-V, there is another product that SolarWinds offers called vMan that can monitor that kind of environment. But in the DPA case, let's go ahead and see what that looks like. So I'm going to click on the virtualization tab, and I'm going to go ahead and click on one of the instances that is on there. By the way, I think this is an AG, so an availability group that we're collecting metrics on, or that we're monitoring. But you can see here that, let me go dive into a day, get a little more zoomed in picture. We are able to view the entire stack. So we always start with the weights. So I want to preface that. But then we go down and we give you all the metrics from a database instance point of view. We collect a bunch of metrics from a virtual machine or guest operating system point of view. We go down to the physical host. So this is our ESXi node, and even down to the data store layer, right? So here, the idea behind this was to give the DBA or give the user the ability to understand, am I being impacted by a noisy neighbor? In other words, is there another virtual machine running on the same physical host that I am that's consuming more than its fair share of resources, causing me to suffer from a performance perspective? And by plotting it out the way that we do, you can see at which layer is actually driving that contention. So in other words, here, if I look at this particular metric here, I'm not sure what this one is, but it looks like that's my total disk latency. But if I were to drill into the 7:50 a.m. time frame and look up above here, yes, there was more disk latency during that particular time, and maybe let's drill in a little bit and see if we can see. Maybe I want to flip to my total weights, but we can see that there were more weights here, but it was predominantly an operating system call or a kind of cluster activity. So if anybody's running availability groups out there from a SQL Server perspective, yes, we did have some elevated latency at the physical host, but I would say due to the wait activity that I'm seeing above, might not have been a total hit to performance issue. Now, the HID cluster API call could actually be impacted by slow disk because we do have to wait for, if anybody's familiar with AGs, during the replication process, once we have our logs, our transaction logs and stuff committed and everything's written to the transaction log, that will get propagated out to any other AG replicas out there. But in order to declare success, that log has to actually get hardened on the receiving side. So that has to be written to disk on that replica. It doesn't have to be applied yet, but it does have to be received and acknowledged that it has been persisted to disk on the receiving end. So that can actually be a pretty decent performance hit depending on resources. Yeah, great question though. But the ability to drill in and see those kind of layers and understand who's impacting or which layer is causing, my end user's pain, that's key.
Absolutely. The last question is more a general question: is does DPA integrate with Orion? So how? Because obviously some of the attendees came across DPA because they were already using products such as SolarWinds SAM or NPM and so on. So obviously I know the answer, but if you can just very quickly.
Yeah, so the answer is yes. That's an easy one. But how do we integrate and what kind of value do we bring? that's probably the bigger picture. So we do expose a lot of our data. Now one thing to mention is we are our own application. So Orion is built on the .NET framework. DPA is a Java application. So if you guys are familiar with those two, they don't necessarily play together. So in order to be fully integrated to Orion, we would actually have to rewrite DPA, right? But in lieu of that, what we do is we make SOAP calls from Orion to the DPA server to pull over data. So how does that look within my environment? What it does is it gives us this database summary, which is pretty cool. So we bring a lot of that data over to Orion to give those that are using it or familiar with the Orion interface, all that database information. So here you can see these are the database instances that I have mapped, that I have fully integrated here. I've got a couple of DPA servers that I'm actually linked into with my Orion server. If I want to, and I know we're a little bit short on time here, so I'll try to speed this up a little bit. We integrate with SRM. So if anybody has the storage manager out there, I can get this kind of visibility in here, and hopefully this will respond quickly. But really it's going to show a mapping of my dependencies, right? So I've got these database instances. I know I'm monitoring them. Now, what storage volumes or LUNs am I dependent on, right? So we do this data mapping, or this probably storage array volumes to database mapping kind of automatically. And I can click on these and quickly see, is my database suffering because, well, my storage is suffering latencies, or has some kind of issue on its side. The other thing we do is we tightly integrate with SAM, Server and Application Monitor, and we again do that mapping between applications and databases so that you get that great picture of that dependency tree. You can see which applications are speaking to which databases. And if anybody has, I forget which version of Orion this was built in, but if anybody is familiar with AppStack, this is also how we integrate in. So you can see your entire kind of dependency tree and its relative health by different tier. So this part is great because, and the reason I love this is that, an end user is probably not going to call in and complain and say, hey, LUN 51 is having high latency. They're just not going to say that, right? What they're going to do
will not be the average user. That will not be the average user calling. Absolutely.
Right. So as an IT professional, how are you going to hear about it? They're probably going to say, "Oh, application, this Exchange server is slow. I can't get to my inbox," or something like that, or SharePoint is just a dog today, or something like that. So this provides us the ability to go ahead and highlight maybe an application, and let me just, I don't know if there's a good one here. I might have to unpack a little bit, but so here's an IIS server, and I'm not sure, since I'm just kind of hunting around here, I'm not sure what dependencies are going to be highlighted here, but here we can see that if I am concerned about the performance of an IIS server, it's like, oh, okay, what database is it dependent on? What transactions are happening? What server is it running on? Is that server a virtual machine? Is that what storage is that host tied to? So we can see here there's a couple of hosts involved, and this allows you to quickly, easy, and spotlight all the dependencies for that IIS server and all the contributing factors, because we know that applications and databases and all these things, they don't exist in a vacuum, right? They all have these massive number of dependencies within our data center, within our IT environment, and getting this quick mapping and ability to see that dependency in this kind of format really makes it easy to start to troubleshoot and make sure you understand basically which discipline to get involved. Do I call my DBA? Do I call my storage guy? Do I call my sysadmin, etc.?
That makes perfect sense. And we were already, to be honest, in the Q&A session. And there's another question that came in that from Robbie that says, what are the main differences between SAM App Insight and DPA? Obviously, App Insight is the super template that SAM developed for Microsoft SQL, Exchange, and IIS. Obviously, that before that Tap Insight came on board, there was a huge difference between the data that you could gather from an SQL database. But after Tap Insight, I think visibility improved massively. But now we have obviously another perspective, which is DBA. So I don't know if you could summarize, in one or two sentences, the main difference between SAM, App Insight, and DBA.
Yeah, and again, great question. So I really think of SAM as more from a health and resource consumption point of view. So if you remember that chart that I had in the presentation where you've got the health monitor and then you've got the performance analyzer. So SAM is great at understanding your infrastructure health, making sure that resources being consumed are not pegged. It can give you the top queries by CPU. But it doesn't really speak to, is Robbie waiting for his query to complete, right? It won't really answer that specific question because now we're talking about performance. So I really want to say that the two products look at it from two different vantage points, and that using both of them in your environment is a really powerful combination, right? Because you get the infrastructure covered, but then you also have the query performance covered from the DBA perspective.
Plus, on the App Insight, it is true that the most expensive queries are highlighted, but as you said before, they're from a CPU consumption perspective, which not necessarily is going to be the metric that is driving poor performance or good performance, conversely.
Correct. And also from a SAM perspective, it might highlight the top resource consumers and stuff, but it doesn't necessarily answer the why. So even if something is taking longer to execute, why is it taking longer to execute? That's what DBA answers.
Absolutely. There's another question from Nigel. This is more towards historical and aggregation. How much historical data can be retained, and at what aggregation, if any? Do you guys aggregate data over time, or what's the retention characteristic?
We do. Yeah, we do, and great question. So what we do is we collect data, and we're collecting data at a very granular level. So we actually do our polling once every second. If people are familiar with the Orion side from an application monitor, I think it's kicked off once every 5 minutes by default. You can get a little more aggressive with that. But we get much more aggressive from a database monitoring perspective. So once a second, we go and do what's called a quick poll, and we gather a very minimal subset of information about weights. We will keep that detail by default again for 30 days. So you get a 30-day look back at your environment. Within that time frame, we're doing constant summarization at a 10-minute level, at an hour level, and then at a daily level. So we will keep hourly information up to 90 days and daily information up to 5 years. Again, all of this is default. That's all configurable, but out of the box, you can go back anytime within the last month or the last 30 days and get second-to-second activity.
I think it's quite important, obviously. Not that you cannot or may not need that detailed information past 30 days, but trying to keep a product responsive and the storage controlled and being practical, I think that 30 days is for a second, kind of polling is quite an achievement there.
It really is, and a lot of times you're right. You will not need that kind of granularity, but when you need it, it's really nice to have. So, and this is just showing as I drill in, you can continue to drill in further and further. And at some point, I'm going to get to, yep, here's my second-to-second activity and exactly when queries started, when they completed, things like that.
Brilliant. I think we do not have more questions. But as I said, I think that we went into the Q&A session unofficially, and we have pretty much answered all the questions that came through. I would like to remind the attendees that when you guys leave GoToMeeting and when you close the session, you're going to be prompted to complete a survey. And for those that have a minute and can complete it, that'll be fantastic, and will certainly help us improve the type of sessions that we provide. And to reward you for that support, we'll be sending you a bag of SolarWinds goodies. So I hope you guys can put 2 minutes there and complete it for us. Perfect. So, Rob, do you have anything more to show us? Probably best to wrap up. I think we went 10 minutes.
Yeah, we went a little bit over the time. Sorry about that. When I get going, I kind of just ramble. But I would stress, if anybody has any other questions or want to know more about DPA, definitely reach out to Jesus and team and let them know, and we'll be sure to get you those answers or that deeper dive into DPA, what it is, what it's all about. There is so much more to this product that I wasn't able to cover just because of the limited time frame. So, but we would love to share that information with you if you have those questions.
There's some other session coming up, right, in 1 or 2 weeks around DPA. Perhaps we can complement, or I'm sure that we will complement the gaps that we could then, I guess, address in this session in the forthcoming week. So,
yeah, that's a great thought. If anything comes up and you can wait that long, but don't necessarily wait that long if you don't want to. We can address things real time. But yeah, I think we're planning another session here. Oh gosh, I forget the date right now, but yeah, you're absolutely correct.
it's too early for you, man. It's 3 o'clock in the morning. So.
It's way early, but yeah, hopefully everybody that attended this call, if you're kind of curious about the next topic, I think was it databases without bounds or something? I forget the.
Correct. Yeah, I think it's around those lines.
I think it is, and the thing we're going to talk about in that one, and this gets into a little bit of philosophical discussion, but basically the concept there is, as we enter this new world of hugely wicked fast clock speeds on chip architecture, a huge amount of bandwidth from a networking perspective, 10 gig E is very, very common. The pipes that we have are amazing. You can throw, terabytes of data or sorry, cache on your servers, storage improvements with SSD. It's like, man, are we approaching a time frame where resources aren't a concern? And if we are, then do we have to change the way that we think about our databases?
I think we have, and we should have a long time ago. I would say, I mean, it's been cheap for quite a while. So, absolutely. Nigel, I see your question. What output reports are available? Rob, I leave it up to you. If you have time and want to cover that, fine. If not, I'll reply to Nigel offline.
Yeah, and I don't mind. So we have a lot of predefined or canned reports within DPA, and if you see my screen here, you can see the types of ones that we do. Some of them are focused around the different dimensions that we collect. So the application, the client machine, the database user, top SQL, things like that. But this can be very, very flexible within the predefined ones. So an example would be top SQL, and then if I go to report options, it lets me kind of toggle different things. I can collect the top SQL statements, but if I want to define my own, I can come in here and look for a certain stored proc, right? So if I know the proc name, the stored proc name, then I can go ahead and type that in, and it'll give me all the SQL statements that have run from within that procedure over the time frame that I'm identifying. So lots of canned reports, lots of abilities to get creative within those canned reports. And then, just like any usual monitoring tool or something like that, you can schedule the reports to run at X time, and that can be emailed to you. So I see this used a lot with people. They get an early morning report so that it's waiting in their inbox for them in the morning during their coffee time. They can review it, make sure nothing's gone terribly wrong in their environment, that kind of thing.
Brilliant. Perfect. Okay, so Rob, I think it's time to wrap up. I really, really appreciate your assistance today. I know how early it is for you, and I think the session has been very, very useful, certainly for me, in order to understand better, the differences between health, performance, and what the difference when you're looking at these two metrics and the impact that it has in your environment. So thank you very much.
Oh, fantastic. And thank you for having me. And I just want to really thank everybody that took a little bit of time, valuable time out of their schedules today to spend it with us.
Brilliant. Perfect. So, Rob, if you can make me the presenter again, and I'll just leave the final slide there. Once again, for those of you that are able to complete the 3 minutes long survey, and we'll be sending you a goodie bag of SolarWinds merchandising, and we really appreciate your support. Thank you very much.